The equipment we're going to be using today is going to consist of two things. A pair of electronic balances, and B, several graduated cylinders. Now, a graduated cylinder is simply a long, thin piece of glass tubing that has a scale marked down the side, and it's used for measuring out liquids. The first thing we're going to have to do with graduated cylinder is put it on the balance. That is, we have to get a weight of the graduated cylinder empty with nothing in it. And there's a correct way to do this. There are two kinds of balances we run into in the laboratory. The first one is the analytical balance. It weighs down to milligrams and has a capacity of about 100 grams. You would use this if you were trying to weigh a small amount of something very, very accurately. It consists of slides on each side so that you can open it and a slide on the top for taking and removing your materials. The second kind of balance we run into is a top-loading balance. The top-loading balance is less accurate than the analytical balance. It's only accurate to 1/100th of a gram, but it has a much greater capacity. It's capable of weighing 300 grams or more of material. And it doesn't have the side shields as the analytical balance has, because it's a less sensitive piece of equipment. And so which balance you would use in lab would depend on what you were weighing. If you were weighing something light and that you wanted a very accurate number for, you use the analytical balance. If you were weighing something that was heavy or that you didn't particularly need a really accurate number from, you could use the top-loading balance. So we have an unknown liquid, and we want to figure out what its density is. And we're going to do that by, of course, measuring its mass and different volumes of it and checking the mass of those different volumes. So the first thing is we have to set up the analytical balance. The first step in using the analytical balance is we have to push the button marked 0, because we want the reading to be 0 when we start the experiment. The next step is to put the container we want to use onto the balance. In this case, we're using a 10 milliliter graduated cylinder for the experiment. We put the graduated cylinder on the balance and let it settle down and record that volume. We then have to take our liquid and fill our graduated cylinder. Keep in mind when you are recording your weights that the analytical balance is recording to milligrams. So the last three numbers you get from those weights are going to be past the decimal point. They're going to be in the 3 decimal places. It's only the numbers in front of the last three places that are going to be actual gram amounts. In the same way, on the top-loading balance, it's measuring centigrams. So the last two numbers on those weights are all past the decimal point. It may not be obvious to see the decimal place just looking at the balances, but on the analytical balance, the last three numbers are past the decimal point. On the top-loading balance, it's the last two numbers that are past the decimal point. Having gotten our weight for the graduated cylinder and written it down on our data sheet, we now need to fill the graduated cylinder with our unknown liquid. And in this case, we wanted to fill it up to the place on the scale marked 3.4 milliliters. Now, in filling a graduated cylinder, you will notice that the water forms a curved surface. This is known as a meniscus. And it's important, if you are going to be using the graduated cylinder correctly, that you realize that when you are taking a reading on the volume in a graduated cylinder, you have to read it at the bottom of the meniscus. We have filled the graduated cylinder so that the reading on it is now 3.4 milliliters. We again check that the balance is 0 and put the graduated cylinder in the container. And we have to record the new mass. So now we have weighed our graduated cylinder and our 3.4 milliliters of the liquid. We now want another measurement, and so we'll continue adding liquid to the graduated cylinder until the reading is 6.6 milliliters, and then we'll go and weigh that quantity. We take it out and add enough to bring the liquid to the 6.6 level on the graduated cylinder. We again check that the balance reads 0. And put the balance in the solution in, and again we have to record the total mass of the graduated cylinder and the liquid. One more and we will have 3 volumes and 3 masses. Now we have 2 masses and 2 volumes. For our liquid, we want a third one, so now we will fill the graduated cylinder up to the 10 milliliter mark with our liquid and go weigh that. We've now filled the graduated cylinder to the 10 milliliter mark. But you see, we have to re-zero the balance before we use it. You have to always zero the balance before using it in an experiment. And so, we now have to record that mass. That's the graduated cylinder plus the 10 milliliters of our solution. And so we have 3 different volumes, 3.4 milliliters and the mass, 6.6 milliliters and the mass, and 10.0 milliliters and the mass of our liquid. So now we have a simple calculation. We have to subtract the original weight of the graduated cylinder from each of our readings of the graduated cylinder and our liquid, so we can get the mass of the liquid that was present in the graduated cylinder at that point. How much the liquid weighed that was at the 3.4 milliliter mark, how much the liquid weighed when it was at the 6.6 milliliter mark, and how much it weighed when it was at the 10.0 milliliter mark. The way we're going to get the density for our liquid is we're going to take our 3 volumes, 3.4, the 6.6, the 10.0, and their masses, which you got by subtracting the mass of the graduated cylinder from the mass of the graduated cylinder and liquid, and making a graph. You are going to have to plot mass versus volume and figure out what the slope of that line is. And the slope of the line you get by connecting those points, and the origin should be the density of your liquid. Which brings us to the second density we're going to do. Now, if we had a nice regularly shaped, like a cube, of solid, we could just measure its volume directly in a fairly simple fashion and take its weight and therefore get its density in a very direct fashion. But if the solid has a very irregular shape, then that's not going to be easy to do, to measure its volume by simply doing some kind of measurements on it. And instead, when we have an irregular shape, it's easier to get the volume by displacement. This is known as doing an Archimedes density. In this case, we're going to take a larger graduated cylinder, a 100 milliliter graduated cylinder, and fill it to the 70 milliliter mark with water, and then weigh the graduated cylinder and the 70 milliliters of water in it and get their total mass. So we have filled our graduated cylinder to exactly the 70 milliliter mark with water. And now we need to get the mass of the graduated cylinder and the water. And so you have to write down the mass, the graduated cylinder and water. Now we're going to start adding our solid to the graduated cylinder. Having gotten the mass of the graduated cylinder and the 70 milliliters of water, we're now going to add our unknown solid to it. In this case, it happens to be a set of marbles. And we're going to keep adding until we get to the top of the scale on the graduated cylinder. In this case, we've added a bunch of marbles to the graduated cylinder, and they of course have sunk down to the bottom, and the water level has risen up. The water level now reads exactly 98 milliliters on the graduated cylinder. So the volume of the water and the marbles is 98 milliliters. So now we need to get the mass of the graduated cylinder, the water, and the marbles. And so we need to write that number down. And so we're adding marbles to the graduated cylinder until the volume on the graduated cylinder now reads 98 milliliters. That's the volume of the water and the marbles. And since we know the volume of the water was 70 milliliters, that means the remaining 28 milliliters of the 98 milliliters has to be the volume of the marbles. And now we can simply weigh the graduated cylinder, the 70 milliliters of water, and the marbles, and get the mass of the whole thing. And that, minus the mass of the graduated cylinder and the 70 milliliters of water, will be the mass of the marbles. And so we'll be able to calculate the density of the marbles by dividing their mass of the marbles by their volume, which we said is the 28 milliliters. And that brings us to the end of today's experiment. You're going to have to take your data and do the calculations, answer the questions at the end of the lab report, and write up a lab report. We'll talk about lab reports in class when class meets.